Okay, here comes part 2 of your review video. Um, we're going to focus on factoring, solving by factoring, and we even have a word problem in here. Yes, you can expect to see a word problem, Mr. Blizniak. All right, so let me see here. Okay, first of all, our types of factoring. GCF. I list that one first because it is always a smart idea to find the GCF first. Greatest common factor. Okay, always do first. Grouping. How do we know when it's grouping? Well, it is 4 terms. Technically, there could be a situation where there's 6 terms too, and it would work out well with grouping. But we haven't looked at any like that, so you don't have to worry about seeing one like that on a test. I just thought I'd mention it. Difference of squares, that's where you have a perfect square minus a perfect square, right? And that'll factor as x plus the square root, or I'm sorry, the square root plus the square root, and then the square root minus the square root, just generally speaking. Okay, and there's 3 types of factorings we use on trinomial. Perfect square trinomial, when you have the lead term is a perfect square and the last term is a perfect square, and if the middle term is twice the product of the square roots, then it factors really easy, just as x minus the square root, or square root minus the square root, or plus, depending on what the middle sign is, and you can do a second quantity or to the second power. All right, trinomials with a coefficient, lead coefficient of 1, something like this. X squared plus, I don't know, let's go with 18. And then in the middle here, let's put, let's put an 11x. Okay, and that's where I list the factors of 18, right? 1 and 18, 2 and 9. And I look at the third term and I see if it's a plus, I'm going to add. If it's a minus, I subtract. Well, in this case, I want to add to get 11. So we'd factor pretty simply like an x plus a 2 and an x plus a 9 in quantities. There you go. And then finally, trinomials that we will group. And that's one where the lead coefficient or the last coefficient, neither of them are 1. And I'm not going to like try to cram it in there. We're just going to do some examples. But those are our 6 types of factoring. So let's look at number 1. I looked at GCF it. I don't see a GCF. But I notice this is a perfect square. Square root is 4x. This is a perfect square, 5. So this is the difference of perfect squares because there is a subtraction problem. We're going to have 4x minus 5 as one quantity and 4x plus 5 as a second quantity. And we're done. By the way, remember, this is also the difference of perfect squares, right? Because I could rewrite it as x squared minus 9. So that will factor one like this, x squared plus 25 is prime. You can't factor him. Okay, let's go down to this bottom one here. It looks like I've got a GCF hiding in there. I think it's a, so I'm going to pull an a out, and I'll be left with 3a squared minus 15a plus 20. All right, I think I'm going to need a little bit extra room here. Let me see if I can't move this problem down. All right. Now, I'm going to take the factor, or the coefficient 3 and the constant 20 and multiply them together and get 60. I must not be in draw mode. And so I'm going to list the factors of 60. Now, remember, I'm looking to add, because this is plus, to get negative 15. Now, if you see the 2 factors we're going to use right away, you go ahead and use them. All right, 3 and 20. Let's see here. Yeah, 4 and 15. 5 and 12. Uh-oh, I'm getting confused. 6 and 10. I'm confused. I took this problem from a book. Hold on one second. Okay, I apologize for that. I took the problem from a book expecting it to factor down further, and all that happened was I got to pull a GCF out, couldn't find a way to factor it. So I changed the problem, and I'm positive that this one factors. So again, I'm going to pull out a GCF, And this time my GCF looks like it's going to be a 2a. So I'm going to pull out a 2a, and that'll leave me with a 6a squared minus a 7a minus a 20. Now I'll multiply the 6 times the 20 and get 120. And in this case, I'm looking to subtract to get negative 7. So I'm going to try to find two factors of 120 that subtract to get negative 7. So 2 and 60, 3 and 40, 4 and 30. I'm not even close, am I? 5's going to go in there. 5 goes into 120 times, so I'm thinking 424. Yeah. Okay, 6 should go in. How many times? 20. 6 times 20, right? 7 I don't believe will go in. 8. Yeah, 8 will go in 15 times. Ooh, I like that. I like the idea of 8 minus 15. So I'm going to rewrite the part in parentheses, 6a squared. And I'm going to do a minus 15a plus, oops, 8a and minus 20. So then I'm going to get a 2a, and I'm going to group. Okay, and I'm going to group like this, put him together, that together, and I'm going to add. Okay, so I think the GCF in this first group is going to be a 3a, and that'll leave 2a minus 5. And in here, it looks like my GCF is going to be a 4, and that'll give me a 2a minus 5. Now, when I go to group the second time, my 2a is still out front. I'm going to have a quantity of 2a minus 5, and then I'll have a quantity of a 3a plus a 4. And there we go. I really like the way that one falls apart. It's pretty simple. It's a good grouping one. It's got GCF involved in it. So, all right, let's drop down to number 3 here. There's 4 terms. My first thought is, let's group it. Only, I think I'm going to rewrite it because I don't see a GCF in these first 2 terms. So I'm going to rewrite it as AB minus 5. No, let's go with AC plus AC. And then I'm going to go with a minus 5B minus a 5C. Yeah, that's what I want to do. Sorry, that got erased there. Okay, I'm going to go ahead and group now, like this. And pull out a GCF A, get a B plus C. I'm going to pull out a negative 5, and I'll get a B plus C. And then I'll GCF one more time, a B plus C times an A minus 5. And there you go. That's it. Okay, looking at this one, number 4. It's a trinomial. Lead coefficient's 1. Before I just jump into factoring, I'm going to check and see if I have a perfect square trinomial. X squared is definitely a perfect square. 48's not. Oh well, I tried. It is not a perfect square trinomial. So I'm going to list the factors of 48. I want to subtract. Okay, so I'm going to list the factors of 48, and I'm going to subtract to get negative 8. So I got 2 and 24. 3 is going to go in, I think, 16 times. That's not negative 8 if I subtract. 4 goes in 12. Hey, what's 4 minus 12? Oh, well, there you go. We're going to get x plus a 4 and x minus a 12 because I said 4 minus 12. And that's it. That's how simple it is. I would not do those by turning it into a polynomial with 4 terms and then grouping it. It's so much extra work to do that. All right, let's take a look at number 5. It's a trinomial. I'm going to check for perfect squares. I got a 5x for a square root, and I've got a 7. If I multiply them, I get 35x, and if I double that, I get 70. I have a perfect square trinomial. This is so simple. 5x, use this sign minus 7, and then 5x minus 7 again. Or if you're like me and lazy, you might have wanted to do this. There you go. Okay, last factoring problem before we go on to the other things. I'm going to factor out a GCF on this trinomial before I do anything. Looks like I'm going to have a 5x, and that'll leave me with a 5x squared plus a 3x plus 1. Okay, now I'm going to look to see if I can factor this inside here. Let's see, let's multiply 5 times 1. It's 5. I need two factors of 5 that add to get 3. There are no such things that you can do. So we are done. All we could do is GCF this problem. And that wasn't a mistake. I wanted to show you that when you factor out GCF that you get a plus 1 sometimes. Okay, let's look at some solving problems. You decide what type of factoring to do. Here we go. We're going to factor out a GCF, get an x squared minus 4. We are not done with this problem because look inside. There is a difference of perfect squares. So we're going to factor this like so. Oops. And now we're going to solve. We're going to set up each part equal to 0. 4x equals 0. Divide by 4, x equals 0. Then we're going to set x plus 2 equal to 0. Subtract 2 from both sides and get x equals negative 2. X minus 2 equals 0. Add 2 to both sides. Oops. And get x equals 2. So x could equal 0 plus or minus 2. Okay. All I did was factor and then solve the factors equal to 0. Because remember that to get 0 in a multiplication problem, one of the factors has to be 0. I don't care if it has 1,000 factors in it. If factor number 738 equals 0, then when you're done multiplying, everything else will turn to 0. Okay, here's a trinomial, lead coefficient of 1. I'm going to think about the factors of 12, and I want to subtract them to get a positive 1. It looks like a 4 minus a 3. So we have x plus 4 and x minus 3 equals 0. X is going to equal negative 4 or positive 3. Okay, by the way, remember how to do a problem like this. 1/5, excuse me, 5x plus 1 times a quantity of 3x minus 7 equals 0. You just set it equal to 0 and solve for x. I'm not going to do them. I expect you to know how to do that. I don't want this video to go too long. All right, I think we've got one more type of problem here. Oop, where did it go? Hello, where are you? Oh dear, I've lost my problem. Let's see. There it is. Okay, the length of a rectangle is 10 feet less than its width. Well, the first thing I'm going to do is draw my rectangle. And I'm getting really good at those. I'm really proud of myself. Okay, and I know the length is 10 feet less than 4 times the width. So I need the width. I need 4 times the width minus 10. Okay, if the width is increased by 20, so my new width becomes W plus 20, right? And then the length is also increased. So my new length just becomes 4W because I'm adding 10 to that, right? So if I take 4W times W plus 20, the area is 1,200 feet. I'm going to distribute, or, if you want, you could do this right off the bat, divide by 4, give you some smaller numbers to work with. So you have W times W plus 20 equals, what is that, 300? And then you can distribute W squared plus 20W equals 300. Now, we don't know how to solve a problem that's equal to 300. We do know how to solve it if it's equal to 0. So we're going to subtract 300 from both sides. And we're going to get W squared plus 20W minus 300 equals 0. Okay, I've got a trinomial. Lead coefficient is 1. I can do it like a grouping thing, or I can just look for two factors of 300 that subtract to get 20. So 300, and let's see, 2 and 150, still too far apart. 3 and 100, not even close. 4 and 75 should work. By the way, if I double 2, I get 4, right? Then I have to cut this in half, right? See, if I do times 2, I have to do divided by 2, and I get the same number. It's very much like the scientific notation idea. Okay, 5 should go in 60 times, and 6 should go in 50 times. Oh man, I'm still going on these factors. It's crazy. Let me group these over and get them out of my way, because none of those are going to work, right? There we go. Okay, so I'm going to pick it up. I don't believe 7 is going to go into 300 evenly. 8 isn't going to work because if I double 4, I get 8. But if I cut 75 in half, I don't get a whole number. I get a fraction or a decimal. 9 isn't going to work because 3 plus 0 is not a multiple of 9. 10 will certainly work. 10 and 30. Oh, look at that. Now, by the way, if you see 10 and 30 right off the bat, you don't have to list all these, okay? All right, so I am going to write it as a 4-term polynomial, and I'm going to do a minus 10W plus 30W minus 300. I know I'm contradicting myself, but got to remember that teaching you to factor with this, turning a trinomial into a polynomial, this is new to me. It's the first year I've ever done it. And so the old me wants to do it the other way. But if I do it the other way, I'm going to lose you because I've never taught you that way. So that's why I contradicted myself. I apologize if it's confusing. Just we know that 30 minus 10 is the same as 20. So I rewrote 20 as negative 10 plus 30. Okay, going to GCF the first quantity and get a W minus 10. And going to GCF the second quantity and get a W minus 10. And I'm going to GCF one more time, W minus 10 times the quantity of W plus 30. And that's going to equal 0. All right, so that means W. Okay, so W could equal 10, or W could equal negative 30. Now, that doesn't make any sense because we're talking about a width of a playground. When I know the original width, it can't be minus 30 feet. You can never have a measurement that's negative. So the original width is 10 feet. Okay, now to figure out the length, I just have to go up to this here and put 10 in. So 4 times 10 is 40, minus 10 is 30. 30 feet. Okay, and then if you wanted to check your answer, you could do this. What did we have to do? We add 20 to the width and 10 to the length, right? So let's add 20 to the width and we'll get 30, and add 10 to the length and we'll get 40, and multiply and we are going to get 1,200 feet, and so it works. Okay, feet squared that is. All right, that's your second review video. It's not too bad. The first one was about 14 minutes. This one's just under 20. So, and you have many days to watch these. Get ready for the test. All right, Mr. Lawrence signing off. Good night, everybody.